look at theoretical and percentage yield. So our learning intentions are to identify the limiting reagent in a reaction, and from this we'll be able to calculate the theoretical yield and percentage yield. So when looking at the limiting reagent, you must ask the question, do all reactants get used up in a reaction? And the answer is that they don't. In a chemical reaction, the reaction that determines the amount of product is called the limiting reactant. So one reactant will get used up completely, and that controls what amount of product you'll produce. And the other reactant that has some spare stuff left behind is said to be in excess. So if we look at this example here, we can see that there is 6 hydrogens and 4 chlorines, and that goes to form 8 hydrogen chlorides, and there's still 2 hydrogen molecules left behind. So H2 is in excess, and the chlorine, or the Cl2, is the limiting, because once we run out of chlorine to form hydrogen chloride, all that's left is some hydrogen. So let's try an example. It says a student weighed out 10 grams of iron and 10 grams of sulfur. After mixing them, she heated them in a boiling tube, causing the following reaction to occur. And they're asking you to calculate the maximum amount of iron sulfite that could be formed from this reaction. So to do this, there is 3 steps. And they are: convert everything from grams to moles, find your limiting reactant, and you'll do that using the balanced equation, and then find your maximum yield. So let's give this a go. So the key thing to have here is always have your balanced equation written out for yourself so that you can clearly see it. So that's the balanced equation that was given in the question, and just to note that we were told there's 10 grams of iron, and we know that that has a molecular mass of 56, and 10 grams of sulfur, and we know that that has a molecular mass of 32. So if we go to step 1, step 1 tells you that you have to convert from grams to moles. So to convert from grams to moles, what you would do is you would divide by your molecular mass, and we know that from the mole chapter. So for iron, we have 10 grams divided by 56, which is 0.18 moles. And for sulfur, we have 10 grams divided by 32, which gives us 0.32 moles. So that's step 1 completed, and I've just moved it around there, so step 1 is up here at the top. So step 2, what we need to do is we need to find our limiting reagent, and to do that you need to look at your balanced equation. So our balanced equation is Fe plus S gives us FeS. So I would always start off by saying that this is a 1:1 ratio. So when doing limiting reactant questions, always choose the reactant with the smallest number of moles. So here for us, that's the iron, because it's got 0.18 moles. So this becomes 0.18 is to 0.18. The reason these are both 0.18 is because the 1:1 ratio. So if I have 0.18 of the iron, I must have 0.18 of the sulfur. And always start with the smaller number of moles. So here I would write down the following. We see that we need 0.18 moles of sulfur, but we actually have 0.32 moles of it. Therefore, the sulfur is present in excess. So just to go over that with you again, you know it's a 1:1 ratio. You always pick the reactant that is the smallest number of moles, and that for us here is the iron. So we have a 0.18 moles of the iron, so we have to have 0.18 moles of the sulfur because they're in a 1:1 ratio. So we've already dealt with the iron, so you look at the sulfur, And we see that we need 0.18 moles of sulfur because of our equation, but we actually have 0.32 from our calculation, so therefore the sulfur is present in excess and the iron is our limiting reagent. So finally, we look at step 3, and step 3 is to calculate your maximum yield. So to calculate the maximum yield, again, we know that our limiting reagent is our iron. So we look at Fe going to Fes. We know it's a 1:1 ratio, but we only have 0.18 moles of the iron, so we can only produce 0.18 moles of the iron sulfide. And what you need to do to find the maximum yield, you need to multiply the 0.18 by the molecular mass of the iron sulfide. And from a calculation, the molecular mass of FeS is 88. So we multiply the 0.18 by 88 and we get that the maximum yield will be 15.84 grams, and that is your maximum yield. Now, that is this question finished at this point. This is like quite a basic question. I'm going to do some more examples with you, and they will get more difficult as we go along, and we'll move away from dealing with a percentage yield. So, the theoretical yield is the yield calculated from your chemical equation, and it is the yield that would be produced if all the reactants reacted completely. So it's basically, in theory, if you had a perfect experiment that your reactants reacted completely, this is what you would theoretically produce. But we in the lab always get the actual yield, so that's the yield that's obtained through your experiment. So you would calculate your theoretical yield and your actual yield would come from your experiment. Putting the both of these together then, we get something called percentage yield, and percentage yield is used to express the amount of reactants converted into products. And this is your formula for percentage yield. You put the actual yield, which you will get from the experiment, the theoretical yield, which you will calculate, and you multiply that by 100. Now, this formula here is extremely important for the next few examples. So when doing theoretical yield and percentage yield questions, I always recommend a set of steps to follow. And the first step is to convert volume to mass if required, and then convert from mass to moles. So volume to mass and then mass to moles. Identify your limiting reagent, and you'll do that using the balanced equation. Then you can go and calculate your theoretical yield and then calculate your percentage yield. And all of these steps will come together in the next few slides with the examples that we do. Okay, so let's do another example that isn't a 1:1 ratio. It says a sample of benzoic acid was prepared using 2 centimeters cubed of phenol methanol with a density of 1.04 grams per centimeter cubed, and a solution containing 6.32 grams of potassium permanganate, according to the balanced equation. At the end, 1.05 grams of pure benzoic acid was obtained. Identify the limiting reagent and calculate the percentage yield of benzoic acid. So I've just rewritten the top equation, the balanced equation here at the top, and I filled in everything that we know from the equation. So we know that we have 2 centimeters cubed of the phenol methanol, we have 6.32 grams of the potassium permanganate, and my actual yield of what I produce is 1.05 grams of the pure benzoic acid. So what we want to do is step 1 is to convert your volume and your grams into moles. So let's do that. So if we look at the phenol methanol, we have it in centimeters cubed. So to find the mass, we need to do the density by the volume. So the density of our phenol methanol is 1.04 grams per centimeter cubed by the volume, which is 2 centimeters cubed. So that gives us 2.08 grams. So to go from grams to moles then, you have to divide by the molecular mass, and the molecular mass of phenol methanol is 108, so you will do the 2.08 0.08 divided by 108, and what you get is 0.019. So next, if we look at the KMnO4, we want to go from grams to moles again, so we're going to be dividing by the molecular mass. And the molecular mass of KMnO4 is 158. So I know I have 6.32 grams of KMnO4 from my balanced equation. So I do the 6.32 and I divide that by 158 and you get 0.04 moles. Now that's the only conversions you need to do. You don't need to do the conversion of your actual yield. You only need to do it for your reactants. So that's step 1 completed. Let's move on to step 2, which is finding the limiting reactant. So to find your limiting reactant, we do only need to look at the 2 reactants that we have. And the 2 reactants that we have are phenylmethanol and potassium permanganate. So write that out. And let's look at our ratios. So we know that it is a 3:4 ratio. Now, when filling in for the actual number of moles we have, you start with the smaller number of moles. So the smaller number of moles is the 0.019. So instead of 3 moles of the phenylmethanol, we actually have 0.019. Now, to figure out the number of moles that you have of your KMnO4 or of your other reactant, you divide the number of moles of your first reactant by the number of moles in the balanced equation. So to get the number that's here, I will do the following. I will do 0.019 and I will divide that by 3 and I will then multiply it by 4. So you divide by the number in front of your first reactant and multiply by the number in front of your second one. And that gives me an answer of 0.019 is to 0.0253. So once you get to this step, you need to look and see which is your limiting reactant. So if I highlight these, I can see that I need 0.019 grams of your phenylmethanol, and that's what I have. So it's more important to look at the KMnO4. If I look at the KMnO4, I see that I have 0.0253. That's what I need. For this reaction to happen, I need 0.0253, but I actually have 0.04 moles present. So to use all of our phenylmethanol, we only need 0.0253 of the KMnO4, but we actually have 0.04. So that means the KMnO4 is my limiting reactant. So that's it put into words there. To fully use all of the phenylmethanol, I need 0.0253 moles of the KMnO4 from here. However, at the start, I calculated that I actually have 0.04 moles of the KMnO4. So that means that the KMnO4 is present in excess. So that means that your limiting reactant is the phenylmethanol. So I've just moved step 2 now up here to the corner so that I can move on to step 3. And step 3 is to calculate your theoretical going to your product. So I can see that this is a 3:3 ratio, but I don't have 3 moles of my limiting reactant, which is phenylmethanol. I figured out that I have 0.019 moles in the last step. So it's 0.019. And because this is a 3:3 ratio, they're the same. So that means I will produce 0.019 moles of my product. So to find your theoretical yield, you must multiply the number of moles of your product by its molecular mass, which is calculated as 122. So you multiply your 0.019 by 122, and you get that your theoretical yield is 2.32 grams. That is your theoretical yield. So the last step is step 4, and that's to do your percentage yield. So you use your formula, which is actual yield over theoretical yield multiplied by 100. Now, I know that my actual yield is 1.05 because that's what it is in the question, and my theoretical yield then is 2.32 because I've just gone and figured that out. So you fill them into your formula, so the 1.05 over the 2.32, and you multiply that by 100, and what you get is you get 45.26%. And that's it. That's the question fully solved. Part 1 said identify the limiting reagent, and part 2 asked you to calculate your percentage yield. So I would just put at the bottom of the question, label it very clearly. Part 1 is your limiting reactant, which is the C6H5CH2OH, and then part 2 is your percentage yield, and that is 45.26%. So they are your final answers at the bottom. So let's try one last example. This question says, a sample of ethanol was prepared using 17.88 grams of acidified sodium dichromate and 11.04 grams of ethanol according to the balanced equation below. Show clearly that the ethanol is in excess and find the percentage yield of ethanol if 2.97 grams was produced. So I've just rewritten out the equation here at the top, and I've written the full formula for sodium dichromate because we're going to need this when we're doing step 1. So step 1 is to convert your reactants from grams to moles. So I'm going to start with the ethanol first. So to convert from grams to moles, we know that we must divide by our molecular mass. So we know that the molecular mass of our ethanol is 46, and we know that we have 11.04 grams of it. So 11.04 divided by 46, and that gives us 0.24 moles. So now let's look at the sodium dichromate. Well, the molecular mass of sodium dichromate is calculated, it's 298. So we have 17.88 divided by 298. And that gives us 0.06 moles of sodium dichromate. So step 2 asks us to find our limiting reactant. So to do that, you write out your reactants. So I've done that there. I've put the ethanol, the dichromate, and the ethanol. So next thing you need to do is you need to look at the ratio. So it's a 3:1 ratio. Now I've told you when you're doing the limiting reactant, you should always go for the smaller number of moles from step 1, and that is the sodium dichromate, which is 0.06. So if we fill that in for the sodium dichromate, we've got 0.06. And that means then for the ethanol, we've 3 times as much of that, so it's 0.18. And I got that 0.18 by multiplying the 0.06 by 3 because it's a 1:3 ratio. So we need 0.18 moles of the ethanol, as we've calculated here, but we actually have 0.24 from the step that we calculated in part 1. So that means that the ethanol is present in excess. We have more of it than we need. So that answers part 1 of this question. So the next thing we want to do is we want to do the theoretical yield. So our limiting reagent is our dichromate, and that is going to produce our ethanol. So I know that that's a 1:3 ratio. However, with the dichromate, I only have 0.06 moles of it instead of 1, but that will produce 3 times as much ethanol. So that will produce 0.18 moles of the ethanol, and I got that from knowing 0.06 is the amount of sodium dichromate that I have. It's a 1:3 ratio, so that would produce 3 times as much ethanol, so that produces 0.18. So to figure out our theoretical yield, we must multiply this 0.18 by the molecular mass of ethanol, which is 44, and that gets me 7.92 grams. So my theoretical yield is 7.92 grams. So the last thing then is step 4, which is our percentage yield, and our percentage yield uses the formula actual yield over theoretical yield, and multiply that by 100. Our actual yield is 2.97 grams from the question, and our theoretical yield is 7.92 from our calculation. So if I fill that in, I get 2.97 over 7.92 in step 2, and part 2, the percentage yield is 37.5%. So that's it for this video. Read over the learning intentions to make